is the reason for the volume expansion. Okay, I'm not sure. So maybe later you can check whether the first factor is overcharge production is the basis for the volume expansion. Okay, so if it is, then maybe we only need to mention one of them, right? Either volume expansion or its overcharge production. Okay, this depends on the paper's scientific contents. But I think because in the author's original writing, when he mentioned about the problem to hinder the nickel flow batteries, he didn't mention overcharge, right? He only told us volume expansion. So I think volume expansion should be more exact, right? Because it comes out most frequently. At least it comes out twice, but for this overcharge only one time, right? Okay. So how about this high performance?
Too general.
Okay. So electrolysis plating?
Yeah.
Yes, right? This is the exact method proposed by the authors to solve this volume expansion of stream solution, right? Okay, so let's take a look at the second one. Nickel-based battery. Okay, it's better, right? It's better. So nickel phosphide. Yeah, let's take a look at this sentence. Here we propose the inside-out strategy to address these issues by in situ electrolysis plating of uniform nickel phosphide and nickel cathode within nickel flow batteries. So nickel phosphide actually is the key part for this electrolysis plating, right? So this one may be acceptable, right? So inside out strategy?
No.
Why?
It's not specific.
It's not
It's not a standard
Yes.
expression, right? This is your design. This is unique to yourself, not a standard, not a widely accepted expressions for the battery field, right?
The
Because
expressions.
it has using this, correct? Means that it is only very special to your work, but it may not be accepted by other people. So if people read this inside out, they may not understand its scientific meaning. But when people read nickel phosphide, they know what it is. Then they read nickel battery, nickel-based batteries, they know what it is. But when they read inside-out strategy, they don't know the exact meaning of inside-out, right? So it's not standard. So it may not be unless this method has been accepted by a lot of people and they follow your strategy and they use inside out the word exactly in their work. Once there exists such accumulations, they can be retrieved on the website, then maybe we can use it. That means it is widely accepted. But now, at least through this page, we cannot understand, right?
Yeah.
Okay. So we cannot understand its exact meaning. We didn't read the other information. Okay? So it's not standard. So voltage efficiency? Voltage efficiency?
Too general.
Where is voltage efficiency?
Voltage efficiency.
Voltage efficiency. Looking at efficiency and the voltage efficiency of 86.2 at a current density of 40 milliampere per square meter of low. So yes, voltage efficiency appeared in the abstract. So is it suitable to be selected as keywords?
Yes. Can. It's one of a standard.
No, it's not general. It's actually a very specific
Specific.
technology for battery systems. Right? So I'm confused. Can anybody tell me whether it's suitable or not? Voltage efficiency? Why no? Who say no?
It's more of a test parameter.
Huh?
It's more of a test parameter. Parameters for
It's
testing.
parameter, right? It's more parameter, right?
So it's not it's not unique for the whole abstract, for the whole thing, for the whole research.
So maybe when you read the whole paper, this voltage efficiency only appear in one section, right? Okay. Anyway, let's move on. Nickel cathode. Is this correct?
Yeah.
To general?
No.
To general?
Cathode?
Nickel cathode, yes, it's a specific.
Yeah.
Cathode?
Nickel
Is cathode?
So let's say the
Yes.
section of nickel cathode.
Nickel
Then
cathode.
how about the modified cathode?
Specific.
Specific
Or it's
modified cathode, right? So what is cathode? Okay, of nickel cathode, right? Nickel cathode. Okay, I think nickel cathode is maybe, right? But for modified cathode, it's not specific, right? Because in this paper, we already mentioned the modification method. Why didn't we use directly this specific words, right? Just using modify, because modify can be carried out in quite a lot of different ways, right?
Yes.
But in this word, modification, for modification, the author has already given the strategies. So it's better that we select the exact words, okay? Okay, so now let's take a look at what the authors, what comes out. So first, can you select, based on the abstract, the suitable title for this paper?
I think it's the B.
Mm.
Which is better? Which is better? I think that the three are all given some values, right? Yes, more or less they have show us the key information of this paper. So which is better? Which is better? A or B or C? C? Okay, so why C? So please give your justification why you think C is better. Because the meaning of the three, I think, quite similar, right?
Yes.
Yes, all the key information of this paper abstract have been shown here. So when you read the three, which is better?
I think it's
C, right? Stability enhancement of zinc nickel flow batteries by nickel phosphide plating. Okay? And enhance the stability of
nickel.
nickel cathode
Oh.
nickel-based batteries by electrodes nickel phosphide plating, right? I think the second one is not so smooth, right?
Yes.
It has some syntax complexity, like
But electron.
stability of and then for, right? But for this one, it's simple, right? Stability enhancement of zinc nickel flow batteries by nickel phosphide plating. Okay. So then how about first one?
The main
Applying to output.
the first sentence of
The
the
third one is mostly concise. Okay. Then how about this one?
the first sentence doesn't state the main objective of the research, but the second and the third one actually just directly states the stability enhancement, so it makes people want to read it. For our time.
Okay. So personally, I like the first one. Okay. Why? Because personally, I don't know which is the best. Okay, I think the three are all okay, acceptable. But personally, I like the first one because the first one put or give the first give the first part of the title to the novelty of the work, right?
Oh.
Applying electrolysis nickel phosphide plating. right? This is the solution of the problem, right? So apply electrolysis nickel phosphide plating to enhance stability of nickel. So it seems that when we read a title, the first few words generally will catch our attention more, right? So when you read it, you can sense if you read it, okay, you can get some sense about the importance of the first few words, right? Correct? Applying electrolysis nickel phosphide. But sure, it has space to improve. Like here, maybe we can change it into applying electrolysis nickel phosphide plating to enhance nickel cathode stability for nickel-based battery, right? To remove some words, meaningless words, right? So that the whole sentence can be simple. Okay, so now let's take a look at the keywords. So keywords from the author is like this: alkaline zinc nickel battery, nickel hydroxide cathode stability, electrolysis more than 1, 2, 3, 4, 5, 6. Okay. Okay.
It's the
So
radius.
which should be removed? Do you see?
Stability.
Stability.
Yeah.
Stability.
Cathodes.
I think should be cathode stability.
Cathodes.
Right?
Yes.
Cathode stability.
Stability.
And actually, maybe we can actually select the keyword based on the information flow of the abstract. Say, first is background. Background is alkaline zinc nickel flow battery, right?
Yes.
And cathode stability.
Yes.
Problem.
Yes.
Then third is electrolysis plating and nickel phosphide, right? This is the method.
Solution. Oh.
And finally, what? So first is alkaline zinc nickel flow battery and cathode stability, right? They are background and problem.
Yes.
Right? And second is how to solve the problem.
Method.
Electrolysis plating and
Nickel phosphide,
right?
right.
So here now we have 4. So do you think these 4 are sufficient?
No.
Can we add more so that paper can increase its retrieval efficiency? Any more? So any more? Can you suggest more? Or 4 is sufficient? The 4 is sufficient.
Suppression of oxygen evolution.
Oxygen, I think oxygen evolution is the reason for instability, right? So the 2 problems, volume expansion and oxygen evolution, are the reason for the stability, correct? No, I don't know. I don't know whether oxygen evolution side effection is a reason for stability, okay? But anyway, maybe you can also change the so-called stability, because stability is not a word appear inside this abstract, right?
Yes.
So maybe we can change the keywords into cathode volume expansion and oxygen, cathode oxygen evolution reaction, right? So to change cathode stability, because stability is not the word shown in the abstract. So after reading the abstract, have you seen the word of stability?
No.
No, right? So if there is no stability inside of the abstract, so maybe we can change it into those that have been shown inside of the abstract, right? So that means the 2 which are
How about
volume expansion, right? So this is one problem, right? And second is oxygen evolution side reaction, or cathode oxygen evolution, right?
yes?
First is cathode volume expansion, second is cathode oxygen evolution side reaction, right? So change stability, because stability is not a word shown in the abstract, right? So just now we have mentioned the principle to select those words that have been shown, right? That are used repeatedly, right? So generally, so if the words has not been shown in the paper, in the abstract, it's not suitable for them to be selected, okay? And so another, before finalizing your list of keywords, refer to common indexing standards. So inside out is not indexed, right? Generally not indexed for the battery research. Okay, so this is a special case for your own work. Okay, so it's not suitable to be used as keywords.
Okay, I have a question about the keywords. How many words can be inside a single keyword? Because from the author, is that it has four? It has in next.
Okay,
Yes.
yes.
The first one is that is it too long, or maybe is there a general rule just how many words can be inside a keyword? Thank you.
How?
I don't know, but I think that for example, outline lithium nickel flow battery many words, right? 5 words. I really don't have any idea about how many words, but generally don't use too much, right? Too many words, okay? And okay, so for this cathode stability, maybe you can change. And I don't think nickel hydroxide should be selected, right?
Yes.
It's not suitable. Okay, so this is
So every section in keyword represent about the sections of the journal.
what?
The every keyword
Yes.
in the it's represent the section of the journal, like for like alkaline ring nickel flow battery for introductions, cathode stability for background like this. So if we put high performance cathode nickels, it represents the result. Is it true or is it acceptable or not?
Okay. You mean that if we give some results,
Yeah.
some keywords?
Yes, yes.
Sure.
Sure.
So if it's not exceeding the word limit, okay, word limit. My understanding is that actually, if you have already proposed the novelty, like electrolysis platinum nickel phosphide, it's already indicate that your work will have some good performance. So sometimes it may not necessary for you to repeat performance, right? Generally, our work, particularly for our analysis research, right? Do you still remember 4 types of research? So the logical, analysis, comparative, and descriptive, right? So for the analysis research, generally we will propose something new. And when we publish, it means that we have already achieved something novel based on the method we proposed, right? So whether we mention the performance or not, it will not influence the significance of the work, right? Correct? And particularly for the keywords, its space is limited, so it's hard for you to insert too many information. Okay? Okay, thank you. So now let's move on to the, yes, okay, yes, electrolysis plating, yes,
Nggak tahu, nggak ada generalnya, nggak ada. Cuma kalau itu kan dia tuh udah pernah banget.
Dia ngomong apa?
Nah, ada sebelah satu keyboard. Keyboard tuh ngomong 2.
Okay, that's good. So in situ, just now, so what's memorize what your name? What's your name? Okay. So Duanqi just give a suggestion that for the abstract, maybe we can use in situ electrolysis plating. Okay. So this modifier will make it more specific, right? Okay. So I think it's an acceptable suggestion. Okay. So, actually, the keywords are just shown here is extracted from the author's original paper. So you see that it's not always that the authors will give a perfect writing, right? So if you see that there is still some space and for improvement. And also the first title A is the author's original title. Okay? So you see, we can still move it, revise it to make it better, right?
Yeah.
So if you read your paper selected, you can also give some improvement, revision to the paper to see whether you can make it better. Okay? Okay, now let's move on to, yes?
I would like to ask the question about title.
Title, yes?
Is it acceptable for us to give verb inside of our title? It's not enough in the form of noun phrases, or should we give a verb instead of verb? Applying the legal five kind of verb.
Yeah, it's actually also a kind of nominal title. You still remember nominal title and interrogative title? It's a nominal title. Yes.
So it is still
It's acceptable, right? So you can also use a sentence. Say, for example, how to change this applying electrolysis nickel phosphide. So how to change it? If we change it, the first one, into a sentence, the title, so we can use application of electrolysis nickel phosphide plating can enhance stability of nickel cathode, right? For nickel-based batteries. So currently, all the three have shown here are all nominal title. Means that the whole title is actually a phrase, not a complete sentence, right? This is the most frequently used one. Yes, because it looks relatively simple, right? Concise. If you use a long sentence, maybe you need to insert some verbs or some auxiliary verbs, something like this. So it's not so concise. Okay. So generally, nominal title is a widely used one. Okay. So you can, yes.
I forget to ask yesterday.
Yeah.
When we talking about the title, sometimes I little bit confused when we must use on in our title on or why we must don't use. Like in our title we use like this. When we must we use this and why we don't do this. When we use this,
Yes.
and yeah, when.
When? Okay, there are different titles. Later, I will share you the PPT files. There are two kinds of titles that will use this symbol.
Yes.
This column, okay? One is the cantina title. Cantina title means that when the work has been published in series, okay? First, second, and third, maybe you can use cantina, maybe part 1, part 2, to indicate this is a series of titles after this. And another is to say abstract. Okay? Another type is
Kalau saya apply, oke.
so here is the cantina title, okay? And this cantina title generally used for a series of related publications, okay? So you see methodologies for hazard analysis, the main title is the same, right? So the difference is indicated by this part 1, part 2. Maybe for this dash, you can change it into columns, okay? So another type is this compound title, okay? So assessment of carbon dioxide corrosion damage, likelihood of failure. So actually for this compound title, it's also used for a series of work, okay? So the first part is the main title, the second part is the difference between different
yeah.
research. Okay? Okay. So now let's move on to the content of experimental, right? We still have some contents to be explained. Okay? For the so last time we stopped here, right? So during the X respiratory quotient, right? When we write the experimental part, although the requirement of the grammar of experimental part are not so strict. Maybe you can write with some minor errors and it can still be accepted. But generally, do not give too much errors, right? Like this, to determine its respiratory quotient, the organism works, and having complete study, the bacteria will of no further interest. So the problem, Einstein explains that they lack consistency subject between main and subordinate clause, right? So for the main core clause, the subject is organism, right? But for this subordinate clause, the subject is the operator, right? Experimental operator, right? So they are not consistent. So we may need to change. Say, for example, the organism, but to determine its respiratory quotient, we did something to the organism, right? And second, having completed the study, we throw away the bacteria, right? So like this. So getting consistency in the subject between main and subordinate clause. So now let's take a look at some of the requirement about tenses. Okay. The first situation is when you describe simple procedure, materials, or samples. We use simple past tense, such as bacteria genomic DNA is isolated from mice species. And the step of procedure before another in a continuous experiment. So we use past perfect tense. Instead, in this sentence, okay, you have two activities. So one is behind another. So in this case, we will use past perfect tense. For example, once the temperature set in the thermostat had been reached, the system was allowed to equilibrate for 30 minutes, right? So the first activity is the temperature set, right? The second activity is equilibrate the system, right? So this is the first activity, this is second, okay? So we use past perfect tense. And if we describe ongoing activity in the experiment, we use past continuous tense, like participants were asked to report what they had been told about postage CTQOL as they were preparing for transplant. Okay, so when they are preparing for the transplant, they were asked to report what they had been told about. Okay, so ongoing activity. Okay, so when we write experimental part, here are some of the suggestions or tips. First, read analogous papers in your target journal and learn the writing requirements. Okay, for some of the journals, maybe, for example, for one step, you can use one procedure, you can use just one paragraph to describe it. But maybe for some other journals, they may ask you to using dotted list, right? Step 1, step 2, step 3, okay? Depend on journal requirement. Second, also click to read, and sometimes they may pick up the glaring error that you missed simply because you were too close to the work, right? So sometimes we are too familiar to your writings. Maybe you cannot identify the errors, but another person who is not familiar with your work, maybe just one glance, they will see a lot of mistakes, right? So it's better. Second, third is check your author's right, okay? And now let's come to results and discussion. So the paper, is this paper I share with you?
Yes.
Simple hydrophobic surface modification for the robot and then still nation performance. Okay. So here are the figure 4 and table 3, figure 8 and figure 9. Okay. So let's first take a look at results section. Okay. Generally, when we write the results, there are two ingredients we should pay attention to. And to start a results, we first generally have an overall description of the experiment, providing the big picture, but necessarily repeat the experimental details previously introduced, okay? So, second is present the data. So, following the broad description is the data, okay? And please focus on representative data. So let's take a look at this example about figure 4, right? So in order, let's take a look at what comes out in figure 4. Okay, I see it. Right. So after figure 3, it is introduction about figure 4, right? Section 3.2. So in order to further understand the element composition and chemical state of PDA, PI, reaction layer, XPS analysis we have carried out, right? So this is a broad description of this experiment, right? But no need to introduce the detail about the XPS, right? So after here, what's the information about glue? Is it also belongs to the broad introduction? Yeah. So this is the location, right? So to tell you where you can find the results. Otherwise, you cannot identify where it is, right? So this is the transition information to tell you where you can find the results of these XPS. Like this is a quite generally accepted routine, right? After you introduce broad information about the experiment, please tell people where they can find the results. Okay? So after this, it is what? It is the results. So the results for this paragraph is this section is quite simple. Just the inner surface elemental composition of both the crystalline PVDF and PVDF membranes were similar, right? This is the result. So how about the information highlighted in yellow color, which proves that there was no penetration of the hydrophilic graphene solution through the hydrophobic pores of the PVDF substrate. So is it still belongs to the results?
Yes.
Results?
Which proof that
Or it's discussion?
discussion,
Discussion, right? So,
Yes.
it's the information that you
Yes.
guess,
Yes,
right?
no
Based
penetration.
on the results, right?
Yes.
It's a
not
guess,
that,
right?
yes.
It's not a solid, concrete data shown there,
Yes.
right? But it's a guess from this data, right? So based on the similarity of this surface elemental composition, you can conclude, right, that there was no penetration. So this is the discussion. So this is the general structure, the results and discussion, right?
Yes.
This is broad introduction, this is the transition, and this is results, and this is the discussion. Okay? Now let's take 10 minutes break.
Yang itu udah di order. Yang kiri itu metode ya. Lu udah gue malah mikirnya gue milih dia nggak roblok
Where is the discussion about this figure 4A? 4A suggests, right? Suggested the successful co-deposition of PDA, PI, and its complete coverage on the membrane surface, right? So the author has divided the information in the figure, the data in the figure, into several sections and made separate or individual discussion, introduction and discussion, right? So this actually will make the overall structure more comprehensible. If you put everything into one paragraph, like the results, it's hard for them to understand, right? And following the figure 4A, as we've seen in table 3, right? So they also make discussion about table 3. Okay. So this is the 2 ingredients, okay? 2 ingredients, figure 4A, and to ascertain. So here is another example based on figure 8, right? So let's take a look at figure 8. So you can see that first is also a broad description, right? To ascertain, that is a target. And to ascertain that the PDA-PI grafted layer did not affect the intrinsic empty performance of the PDA-P membranes, a baseline test was first conducted by using 3.5 weight % sodium chloride solution, and the results are shown in figure 8. Okay, so this is the broad description, right? And second is it can be observed that the permeate flux is comparable to that of throughout the operation, and this is the results. Okay, and what's the function of these three lines? Which suggests that the grafted layer did not provide additional resistance to vapor transfer through the hydrophobic pores. So is it still data or it belongs to discussion?
Discussion.
Yes,
Discussion.
discussion. Okay, discussion. So, and also for figure 9, so the first sentence is the results, and the second half is discussion. So you can see some characteristics of results and discussion, right, based on here. Say, for example, discussion, generally we will use some words like proof, so suggested, indicates, something like this, right? It means that this part is discussion. And so when you write the results section, try to be clarity, okay? The description about results should be short and sweet without verbiage. And the results need to be clearly and simply stated. Why? Clearly, because results constitute the basis for new knowledge, right? So the contribution of any research is novelty, and novelty, the base for novelty is what you actually confirmed, right? So your data is confirmation of your novelty, right? Because you propose some idea, hypothesis, right? So, and then you do experiment to try to prove it, and the data is the concrete proof for your new idea, right? So, to explain them clearly, or to state them, introduce them clearly. And also avoid redundancy. Repetition words of what is already apparent to the readers from examining the figures and tables, right? Here is just one simple example. It is clearly shown in table 1 that Noxalan inhibited the growth of N, raw, okay, I don't know how to pronounce it, okay. So the sentence can be changed into this format, right? So you see it's much shorter by removing several words, like it's clearly shown, right? And sure, sometimes for variation, so that the whole writing is not so routine, you may add some of these structures, right? To make some variation to the writing. Not necessarily all sentences like this, right? So, and now let's come to discussion. Just now we have already see some examples about discussion, right? So the principles, generally, what is discussion? So discussion tell us or reveal the principles, relationships, and the generalizations shown by results, right? So just now we have with some discussions, we can see that here which proves, which suggests something like this. This is what? These sentences told us the generalizations, right? Shown by the results, okay? Then it's not sufficient to just based on the data to discuss about the principles, relationship, and generalizations. If there exists any exceptions or any unsettled points, okay, please point it out and define them, okay? And never take the high risk alternative of trying to cover up or falsify data. Okay? So, for example, for some of the information shown in your figures and tables, you cannot explain them logically, okay? So please accept or write it out. So for this point, we did not find a proof or we did not corroborate it, something like this. So maybe this is a point for further research. Further research. So do not
Cover up.
escape. Do not cover it. Okay. Then how your results and interpretations agree or contrast with previously published work. Sure, this is a very critical point because even for some of the experiment, you follow exactly the same procedures using the same materials, maybe the results will be different. Yes, you will think that, hey, I have done something quite similar or exactly the same, but actually because you are two different papers, you are two different experimental labs. So maybe there are some hidden factors that influence the apparent phenomenon, right? So in this case, it's better that we explain or make a comparison. Okay, for example, in my students' research, okay, okay, and so in one of my students' research, he had made a review about several papers about crystallization or scaling on membrane surface, right? So for different papers, say the main material is polyvinyl alcohol, okay? So for 2 to 3 papers, they all use PVA as the surface materials. PVA, we know it's a hydrophilic material, right? It has many oxygen groups on its chains, okay? But for some of the research, they found that there exists a sodium chloride, not sodium chloride, there exists a calcium sulfate crystallization on membrane surface. Yeah, the same PVA, the similar structures, okay? But for some research, nothing on the surface. Yeah, it's quite strange. Why? For the same material with the same microscopic and the nanoscale structures and sub-nano structures. For this, it has some calcium sulfate crystallization scaling on surface, but for there, nothing. So, in this situation, for example, you have carried out some research and find here, but when you make a critical review about other research, you think that there is no, you find that for their paper, they didn't report any scalings on the surface. It's better that you give some briefings about these comparisons. And if you can find any underlying mechanisms to explain the differences, it's better that you give. Try your best to explain it clearly. But if you cannot, just accept, just admit it, right? And tell maybe in the future better that we carry out some mechanism evaluation or exploration to understand the differences between two phenomena with two different phenomena with same materials, right? So this is the 3 components to be attended when you write the discussion. Okay, first is surely your data and their generalizations, relationships, and principles. And second, any exceptions and unsettled point. And third is comparison between different works. Okay. So here, then I will not explain anymore. So you can read this paper and find that it's quite clearly written, right? Now, there's one point about discussion section in your particular attention. That is discussion versus introduction. So we do the research. When we write the introduction, we have set some targets, right? And so we do the experiment is to answer these targets, right? To answer the questions that proposed in the introduction. So how to answer it? Actually, you will use the discussion to answer it, right? So the discussion will tell you whether the results have fulfilled your research target or not, right? Because data itself, just a practical existence, it itself will not say anything. Only by discussion, by conclusion, you will tell us whether this data can prove your proposal or not, right? Correct. So discussion will answer the questions. Okay. So the introduction and discussion should function as a pair. Okay. The introduction should have posed one or two questions, while the discussion should indicate what the findings say about the answers, right? So, and the introduction commonly moves from general topic to your specific research, whereas the discussion can do largely reverse. That means a well-structured discussion first states the main finding in the specific work, then discuss how they relate to findings of previous work, then implications and applications, and sometimes future research. So this is the different characteristics of introduction and discussion, but their relation is here, right? Discussion should tell you the answers to the introduction, to the questions in the introduction part. Okay. And so here is example. Finding this paper, the answer for the following questions, right? Which part has answered the question posed by introduction? Any implication or future research proposed? So when is the questions in the introduction? What are the questions in the introduction? So this study aims at developing robust membrane surfaces with anti-fouling and anti-wetting properties to be used in direct contact membrane distillation operations, water recovery from produced water, right? So produced water means water containing some oils during some extraction of natural gas, okay, from the rocks. So specifically, a complete membrane with generous wetting properties when fabricated by single-step cold deposition of hydrophilic layer on the outer surface of hydrophobic PVDF hollow fiber substrate. And the surface chemistry, wetting property, and structure of modified membrane were studied comprehensively. Subsequently, bench-scale DCMD experiments were carried out using a series low surface tension solution, and the performance of modified membrane were analyzed and compared against those of pristine. And two. Okay, so the questions in the introduction first is the hypothesis, right? What's the hypothesis? Hypothesis means that the method by co-deposition of PDA-PAI can deliver robust Janus membrane, right? This is hypothesis. And second question is, the other question is actually related to target, right? They want to know whether this method can produce membrane with anti-scaling and anti-wetting properties, right? So first is they think this co-deposition could deliver stable membrane. And second, the stability is tested in terms of its anti-swelling and anti-wetting, right?
Yes.
So these are the three questions you should answer, right? Whether it is stable, whether it can anti-scale and anti-wetting, right?
Yes.
So where is the answer? Okay, I have already shown here, right? Saline feed with 4 types of surfactant, right? The author are testing 4 types of surfactant. So we know surfactant is a material that can easily wet in many surfaces, right? So they use these 4 types of surfactant with different strengths in their wettability to test whether the membrane can sustain wetting. Okay. Second is that surfactant stabilized controlling in water emulsion. Okay, I just make a mistake. It's not anti-scaling, but it's anti-fouling.
Falling.
Okay, yes, anti-fouling. Okay, so anti-fouling. Fouling is generally due to organic foulant. So for section 3.42, they use oil surfactant stabilized petroleum water as the feed solution to test whether these oils will adsorb on the membrane surface. So absorption, if absorption takes place, means fouling occur. But if no absorption, fouling is not happening. So the author has made this test, right? So these two sections answer the question of anti-wetting and anti-fouling respectively. Then how about robustness?
Oh, robustness.
Robust means stability, right?
Yes.
It's strong. It can sustain a long time. So how to understand or how the author answer the hypothesis about robustness? The question of robustness.
Robust.
Okay. And as you are not doing research in this area, so you may not understand some underlying principles of yes, okay, anyway, I will explain to you, okay? So robust means actually means stability, right? So in membrane or in other functional materials, generally when the material is stable means that its chemical and physical structure didn't have changes, variations during the testing, right? So when the structure in terms of chemical structure and physical structure are stable, its separation property and the other properties will also stable. So actually the author, you see that they have tested this membrane within quite a long time, right? 120 hours, 150 hours. So during this long term, the performance of the membrane did not degrade, right?
Yes.
Some of them. So then we can make the deduction, right? Based on this structure and function correlation that the membrane is stable, correct?
Yes.
So because its performance is stable, that means its structure did not change, right? During this test. So based on this information, we can conclude that the membrane is stable, is robust. So by this manner, we answer the question posed by the hypothesis, stable membrane. Okay? So this is the underlying principle. Okay, it's not a explicit principle. Okay, so it's underlying principle. Okay. So and now let's move on to some other points for you to take care of. First is attitudes when making discussion. Because making discussion actually needs you, actually it's a kind of guess, right?
Yes.
So sometimes you may not so sure about whether your guess, the theory is correct or not, okay?
Yeah.
But don't be shy, okay? Try to discuss theoretical implication of your work as well as any possible practical applications, okay? So sure, don't be shy. Doesn't mean that you can discuss randomly, okay? You can say anything you think. Generally, please also try your best to identify from other researches any basis or any support for your discussion, okay? So for example, over here, I just now mentioned about this, okay? So, and when we make discussions, I cannot say, oh, okay, maybe this is due to God, right? don't say like this, okay? You need to what? And you need to try to search some website, right? Try to search from website. Maybe for some of the research, they have similar findings. For some other research, not necessarily based on membrane, maybe based for some other applications. Say, for example, actually, this sodium sodium sulfate crystallization and the scaling is a very common phenomenon in many metallurgical processes because calcium sulfate is a very common component in many metallurgical fluid, right? So scaling inside of the pipelines, correct, is a common phenomenon, right? So maybe you can search some papers for pipeline scaling, right? To try to explain what you have find in your own research. What kind of pipeline will not have scaling? What kind of pipeline will have scaling? So what's the differences between this pipeline or the tanks, right? For some tanks holding the solutions, they may also have scaling, right? So, and so we can try to search some. Oh, sure, if you really cannot find any feasible explanations, then try to admit it, okay? This will be a further research point. And state your conclusion as clearly as possible. So this is attitudes when making discussion. And discussion section also have this principle that is define the scientific truth. In showing the relationship among observed facts, you do not need to reach cosmic conclusions. Although we will make some generalizations, but it doesn't mean cosmic conclusions, okay? So, seldom will you be able to illuminate the whole truth. Yes. More often, the best you can do is shine a spotlight on one area of the truth, just one point. And when describing the meaning of your little bit of truth, do it simply. Do not use verbal language and fancy technical words, okay? Such as, oh, my findings can solve the problem of lithium-ion batteries. Okay, this is too what?
Too much.
Fancy, right?
Yes.
So maybe we can only solve one problem, right? But do not use fancy words or exaggerating or something like this, okay? And so now let's come to, still have time. The thesis usually results in discussion. So if you describe table, image, or graph, use simple present tense. Okay? This is different from experimental part, right? For experimental part, generally we use simple past tense. But when we describe the results, tables, images, graphs, simple present tense. Such as figure 3 shows the experimental procedure, okay? And when you introduce specific results, simple past tense. So why table, image, and graph and results are all related with results, right? So why for this case it is simple present tense, for this case it is simple past tense. Such as the studies show that the number of examples through business produced.
Because it's already been done.
Huh?
Because it's already been done.
It's already been done.
Yeah.
Yes.
Okay, yes. So for table, image, or graph, and I just tell you tips how to memorize the differences. Okay, for image, table, and graph, you think just that they are existing along with you at present, right? However, for the specific results, just as you said, it's already belonging to past experiment, right? So please use simple past tense. Yeah. Okay. And so when you explain results, you may use some model verbs indicating a speculative attitude, right? So the value differences may this is discussion, right? Originate from magnetic variability, right? So when make comparisons of different results using simple present tense, the last value is in good agreement with the results from on-site evidence, okay? So it's hard for you to memorize all these rules. Maybe you just memorize these examples, okay? And so for figures and tables, etc., so you can use Microsoft Visual, Adobe Illustrator, Photoshop, PowerPoint, and Origin to help you to draw the figures and tables. And for example, here, right? Here are some beautiful schemes, right? Yeah, sometimes PPT is sufficient, right? And here's a beautiful figures. So now let's come to the contents. Contents in conclusion. Briefly introduce the new findings and new points, new series, etc., and conclusively state application, prospect, limitation of research and direction for future research. And conclusion and abstract should have some complementarity. Okay. So for example, for the abstract part, you will highlight the major findings, right? Some data trends, important data, and important data trends, right? Then in the conclusion part, you may give some explanation to this data. Why, or the mechanisms for this data, right? Why this data is good or not, right? So this is supplementary, okay? So this is the contents in the conclusion. And also there is acknowledgement. So acknowledgement is useful for showing appreciation to those who have made contribution to the work, but do not meet the requirement for authorship. And so, for example, the recipients of gratitude and acknowledgement usually include experiment staff assisting research, organization or personal providing equipment, testing, etc. for research, owners of documents, images, literature, research idea, and design granted reprinting and citation rights. So for personal giving suggestions, reviews, and other assistance during paper writing. Okay. But funded projects, okay. So for the personal giving suggestions, reviews, and other assistance during paper writing, I think for this situation, maybe the personnel could be included in your author list, okay, because it has already get involved in some scientific contribution. So it's better to include them into your authorship. Commonly used expressions and guide authors. Editing of acknowledgement should follow the convention of targeted journal, okay? And so, for example, funding information in acknowledgement and funding information footnote of first page, right? For most papers published in English journals, so funding information is in the acknowledgement. But for funding information in Chinese journals, they are often given in footnote of first page. And so here is some example that you can see. So here are some funding in China, their English version. Okay, so like the most important is National Science Foundation for distinguished young scholars. The general program, they were joint research from the young scholars of Hong Kong. Okay, so here are some reference citation styles. For citations, we can have APA citation, we have Harvard citation, and we have MLA citation. So APA means American Psychological Association. So based on this name, we can already conclude that generally this APA citation is for some publication related to psychology, right? And so citation is a way of giving credit to researchers for their intellectual works that you utilize in your research. So do introduce this part of information in a very careful manner, okay? For some of the researchers, when they write a paper, they didn't give attention to whether the number is correct or not. Sometimes the cited information listed in the reference part mismatch with the information in the main manuscript. Okay, so this is not acceptable. So APA, this is the general manner for APA citation. Okay, so they used in psychological, educational, communication, and other social science disciplines. So for Harvard citation, and this is the writing So it's widely used in academia of Commonwealth countries and generally for natural science related fields such as physics, chemistry, and biomedical science. And so here is the MLA. It's commonly used in humanities papers. So I think that for most of us, maybe it's Harvard type is the major one, okay? So revising your writing. After you finish your writing your paper, you need to have some revision, right?
Yes.
So here is some of the suggestions. First, good writing means good revision. Okay. Generally, first draft is not acceptable in many situations. I think that after you submit your paper with its final version, when you go back to take a look at your first draft, you will not understand what you are writing in some situation, really. Okay, so you're not alone. No one will read the early draft, and no one cares how rough they are because they will not be submitted. Okay, so quite comforting. Okay, so revision is not just for students or other beginners, researchers with long success in revise their work. Okay, nobody can boast that I can write a paper within just one day, one night. No. Even DeepSeek, even AI, yes, they can draft a complete paper, but I don't think it is qualified for submission. Okay, you still need to revise it. Okay, although nowadays paper writing assisted by AI is not inhibited, but AI cannot generate a perfect paper. Okay. So you still need to pay your effort. And so do you revise your work? Yes, if I'm lucky, only about 10 times. So 10 times is really a small number. So this is general procedure, right? Show it to others. Generally, these others means your supervisor, okay? Or some situations, your colleagues, if assigned by your supervisor. And the reviews by the feedbacks, so several cycles finish, then you make submission. Okay, later, next chapter we'll learn something about how to make submission and how to answer the review comments. Okay, here are some questions as guidance. So does the manuscript include all the information? Should any content be deleted? Is all the information accurate? Is the content consistent throughout? And is everything logically organized? Is everything clearly worded? Okay, so when you ask these questions, generally, please ask these questions when you write, okay? Do not ask it separately when you are outside playing, okay? Do not ask. When you write, okay, list these questions, and during writing, ask yourself, okay? And who can help you? An expert in your research specialty, someone in your general field, an intelligent general reader, a professional scientific editor. So I think that the first one is the best choice. This expert is your supervisor, okay? Try to catch your supervisor, okay? And so, conclusion. So reading makes a full man, conference a ready man, and writing an exact man. Okay, so after you practice several times in writing one paper, many papers, finally you will find that you are very careful when writing something. You will not miss any data. Once you see a data, you will have a lot of questions. How this data comes out, and whether this data is accurate, what's the difference between this data and similar data? So you will come out. Many questions will come on your mind. So now you are a scientist, okay? So, and so assignment 5. Look at, I will have some revision to this assignment 5. Okay, it's also a brief work. So after I made revisions, I will send you. Okay. So I think I finished this chapter. So next chapter we'll learn something about how to make submission and how to make reply to your to reviewers' feedback. Okay. So any questions regarding this section? This chapter? Any? So last week, 4 hours will be given for you to present your group work. Okay, so last week, this is 12th week, right? So next is 13th.
13, yes.
So 14th is the week before next, after next. So you have
All of
1 week, still more than 1 week, maybe 10 days to prepare your oral presentation. Yes.
Presentation for the paper that we discussed before.
Huh? What?
If for the presentation, yes, it's the paper that we discussed with our group before.
Yes. The group work, that's simple for all the groups. You will always select one paper.
Yeah.
Okay, that's good. Just that paper, okay? Present. So any questions?
Enggak. Honestly, kita sulit papernya loh. Kemarin lah metodologi oke lah gitu. Aku baca lagi ngomongin apa?
Gua udah bilang ke Bang Fajar ya, Bang, susah banget nih papernya. Challenge Bang, challenge.
Susah cok, paper dari dia cok. Paper dari kamu apa? Bang Fajar. Papernya dari kamu apa Bang Fajar?
Susah nih, susah.
Any questions? Not free discussion. The discussion can only be regarding what we just learned, okay? Okay.
I mean, the part of the method original particles is
Kasih waktu buat coding.
so everyone can use the same result in the method. So my question is the principle same if we want to produce a review paper? Is the methods in original article the same? I'm confused to write the like differences between the review article and original paper from the methods. I mean, if we make the original paper in the method, I just write the word of the step, and others can copy and make the same result. Right? But my question is it same for the review paper? What things I can include in the method in the review paper?
For review paper, yes. Generally for review paper, we will highlight knowledge. Knowledge. That means, for example, if it is a design, we try to highlight the knowledge. Yeah, this knowledge may be a kind of method, right? So when you review the paper, you need to rephrase. That is, do not directly talk about the paper. You need to rephrase to describe the knowledge. Okay? And what comes out from this knowledge? Actually, I need to get out of it. Then you want to see maybe same question, not mine.